Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Ali El-Moursy. We are recording the lecture number 21, part 1 for the microprocessor class. This lecture and the next lecture will be for solving the problems of assignment number 2. We have 4 problems for assignment 2. The first 2 will be solved in the first part, and the second 2 will be solved in the second part. Let's first read the narration of the first problem. Problem number 1 is stating that assume Bx contains the offset of the beginning of a list of double word-sized constants in the data segment. Assume Dx contains the offset of the last item in the list. Determine the number of constants in the list. So actually the problem needs me to count or to calculate how many items in the list, and the size of each of them is a double word, means 4 bytes. So this is the narration of the problem, and we will now switch to the board in order to see how can we solve such a problem in assembly programming. So students, the problem 1 in assignment 2 for the microprocessor, you have to read the problem very well. You have to understand how the memory is laid out, what are the content of each location or each register, in order to successfully put a design for the problem, okay, and then go to the coding. Don't rush with the coding. So the problem as it reads indicates to you that there is some array in the memory. This array of elements, each the list of elements here in the array of a double word sized variables. Double word size. Okay, so double word means each element of my list is 4 bytes. The Bx register is pointing to the offset of the first element in the array. The Dx register is pointing to the last element of the array. So if we call this array element number 0, that means here I have array element number, okay, n minus 1. The total number of elements are n. Agree? So we need to design a very simple small program that actually counts the number of elements in the array. So my program, I have to, this is the description of the problem, the layout of the problem. Okay, description. I have first to design my program before rushing into the code. So here is the code design. The logic that I will apply in steps. What are the steps that I want to do? I have Bx, I have Dx. Okay? Remember that Bx and Dx are, if in order to go from one element to the next, I have to increment Bx by 4, because each element is 4 elements. Each element is 4 bytes. Okay, so so that means the first address here, if I call that the first element is at bx, the second element, which is element number 1, at bx plus 4, then bx plus 8, then until I reach mean the dx. So the design is first to subtract dx minus bx. This subtraction will give me the number of bytes between bx and dx. Agree? It will give me only the number of bytes between them. So it is the number of bytes for the n elements, or for n minus 1 elements, for n minus 1 element, because this last element is not counted yet. Okay? So, the first subtraction. Remember that I don't want to change either the value of bx or the value of dx. So, that means I have to store the minion, which is b, d. طبعا هنا in this subtraction, dx act as the minion, will bx is the subtrand. The minion should be stored somewhere before I do the subtraction, not to lose the value of dx. Then, after this subtraction, in order to convert the number of bytes to number of elements, I have to divide n minus 1 from step 2 by 4. This will convert the operation from the number that we have, from the number of bytes to the number of elements in the array. Step number 3 is to add 1 to the number that we get in 2. You add 1 to result from 2 to get n. Agree? Make sense? Now, how to perform each of those operations? Now I can go to the code, watching the following. That I don't want to overwrite dx. That means dx should be stored somewhere else before I do the subtraction. Second is the division. Here I am dividing by 4. So there are 2 methods of division. I can either divide, use the div operation, which means I have to involve ax, okay, and dx in the operation, because I am dividing by 4. Okay, I am dividing a word by 4, so that I have to actually involve ax at least in the operation. Or this is one method. Or I can do the division, since it's division by powers of 2, I can use the shift instruction for the division. Okay? Agree? Then, next, the last operation is to add 1 to the content, so I will get the answer. Okay? So this is the assembly code. First, I will move dx in cx. Okay, moving dx to cx in order to perform the operation through cx instead of dx. So I don't want to lose the index dx that's pointing to the last element of the array. Then sub cx and bx. This is actually copying. copying in Cx. Okay, then the second step is to subtract sub Cx comma Bx. So this actually will put in Cx the value of n minus 1 multiplied by 4. This subtraction. Okay, then I have to either make the division first or adding 4 to this. Another way, I can add 4 to this to get the n and then make the division. Okay, up to you. Then I have to divide. Instead of divide, I want to shift. So I will shift this unsigned or signed shift. This is unsigned. So I will do a logical shift to the right, Cx, comma 1. This will divide Cx by 2. Will give me n over 2. N minus 1 over 2. And then do another shift for Cx and 1. So will give me Cx now equals to n minus 1. Finally, increment Cx, so which actually Cx now equals to n. So I will get the number n that he was looking for in the problem definition. Agree? Okay. So now this is actually, come on, this is assignment to problem number 1. This is the solution. As I mentioned before, this is not the only solution. There are hundreds of solutions for this problem. You can, each of those steps, you can do them in a different ways. Okay. However, mathematically, I need to do this operation mathematically. Okay. So now we are solving problem number 2 in assignment number 2. The problem is actually want to multiply a number in a double word in the memory, and this variable in the memory is actually defined in some location in the memory called W var. So the offset of the parameter is called W var. Okay, you want to multiply this location in the memory of a double word by 120 without using multiplication. Here, in order to solve this problem, I first have to do kind of an assumption, because actually the question did not specify whether the number here in this memory location, whether it is signed numbers or unsigned numbers. So we will solve this as if it is unsigned number. The other thing that indicated in the problem is that he wants to do the multiplication without multiply. Is it ever possible? Yes, it is possible. How can I do that? We learned that the shifting to the left instruction is actually multiplying the register or the memory location by 2. But this only valid for two restrictions. You shouldn't lose ones on the left. This is one. The second thing is that you have to multiply in powers of 2. The number that you want me to do the multiplication for is not powers of 2. It is 120. 120 is not power of 2. So I have to think about a solution for this. So assuming that the number is unsigned number, and I want to multiply by 120, so that means I have to convert this operation. So let me call this parameter x. So now x needs to be multiplied by 120. How can I convert this multiply operation, okay, into a shift operation? That means that this number should be converted to a number that is powers of 2. Okay, and if we analyze the 120, that we can find the different ways for representing the 120 as it is a powers of 2 number. We can write 120 as 128 minus 8. This will give me 120. But now I have an advantage of having this is powers of 2 and this is also powers of 2. So this is actually x should be multiplied by 2 to the power 7 minus 2 to the power 3. So if I actually, so now I want to do 2 or 3 operations. I can multiply x with 2 to the power 3 minus multiplying x with 2 to the power 3. This can be performed through shifting to the left. How many times? 7 times. However, this shifting should not leave away the shifted out bits. The bits to be shifted out should be shifted back into a bigger sized number. So actually, the number here, if x is originally, if x is a double, is a word, so if x is a word, that means x shifted by 7 locations should be stored in x multiplied by 2 to the power 7 should be stored in a double word. Again, this should be stored, shifted 3 bits, means it's also a shift to the left 3 times without losing the bits. Okay? And the result will be in a double word. I can call this y. I can call this z. If I subtract y from z as double words, I will get the answer that I'm looking for here, which is, if I call this maybe w or v, okay? So this is effectively equals to the result v. So I want to get v. Great, makes sense? Now, I have to be careful that I'm assuming that x is unsigned number. This is one thing. The second thing is that the shifted to the left bits should be shifted in some other register. So that means I need, so now let's talk about the steps of the design. So this is the mathematical work of the problem. The design of the code. In the design of code, I wanted to load x in Word. Step number 2, extend x in double Word. And then I have to go into a shift operation, shift 3 times to get what? To get Z. Okay? And now I have to utilize 2 registers, because there I don't have a double word register. So I have to do this through a 2 a two word. Let's put it here. Okay, so double word means two registers. Agree? Then shifting three times without losing them. So this shifting operation, I have to do it. There is no instruction that actually allow me to shift out a bit from a register to the other. But we have an instruction to shift one bit out to the left outside one register and insert this bit where into the carry flag. Then shift in the shifted out bit from the carry flag into the other register. So using this mechanism, I shifted out the bit from here, shifted inside the number here. This shifting can be either done through either shifting with carry or shifting through or add with carry. Both will do the same. So I will repeat this three times. So which will actually give me what? This will give me the Z. Then I have to, step number 4, repeat. So store and store Z in new registers. Then step number 4 is shift again for 4 times to get me to get Y. Okay, using the exact same mechanism. After getting Y, so I have Z in 2 registers, I have Y in 2 other registers, and finally I will do what? I will subtract, okay, perform double word subtraction. How can we do a double word subtraction? We will see in the implementation. Great. So this is mathematically what we want to do. This is actually the flow of my code. Now it's time for me to pick some registers to perform those operations. Okay. And finally, I will get my answer. The question did not tell me to store it anywhere. So we can store it in the memory, or we just have the result in the registers. It depends on the requirements of the problem. Let's store, perform after subtraction, store the result back in the memory. Agree? Now comes the implementation of this code design. Okay, so we will erase this to give me a little bit of space here in order to actually do the coding for this. Now maybe it is the moment for you to pick the registers. Okay, the registers, you can pick any set of registers. Okay, you have actually the general purpose registers. You have 4 of them. So those 4 registers could be enough for you to do the work. Or you can also assign the I, okay, as the registers, as a temporary registers. Okay, remember that we cannot use here shifting 3 times at once because I'm losing the bits. I have to do this repeatedly. Okay, so now go to the code implementation. Code implementation. the data segment. Data segment has two labels, W var define word with a question mark. And I have the result. I will call it the result. This is define double. Agree? And a question mark. So I put the definition for my data segment. Now my code segment. Step number one. In step number one, I want to load X into a word. Okay? Into some word. Okay? So we can maybe use the DX and AX for loading the value of W var. Okay? So X here representing W var. So here I will first move in the AX, I will move word PTR W var. Okay, loading the value into AX. And we'll move in DX the value 0. Now I have the content of W var is now stored in the double word AXDX. Together is now carrying the value of memory W var. Here I used what we call the zero extend rule. Since we assume that this is an unsigned, so I'm just loading this into AX and populating DX with zeros. So it's kind of a zero extend rule here. Okay? So now this is actually step number one, and this is step number two. Step number three needs a little bit of work here. I want to shift out one bit from AX into the carry flag, and I want to shift it back into the DX. Okay? How can I do that? Shifting to the left, okay? The bit from AX, okay, will automatically puts the most significant bit of AX into the carry flag. Shifting arithmetic to the left of AX and 1. This automatically will actually move the value, the most significant bit of AX will go where? Into the carry flag. Into the carry flag automatically. Okay? The most significant bit of AX. This shifting, and automatically it will insert a 0 from the right into AX. So it is shifting AX by 1 bit. Now I want to take this bit and insert it inside DX. Can I do that? Yes. We have an instruction called rotate with carry to the left. If I rotate with carry to the left for DX for 1 bit, this is automatically will take the bit from the carry flag and insert it. So I'm rotating to the left. Okay, so considering carry flag is part of the DX register and insert it to the left of the DX, and the last bit or the most significant bit of dx will be shifted into the carry flag, which is insignificant because actually dx carries the value 0. It has nothing. So this bit will be inserted inside the dx register. So these two operations will actually shifting or multiplying the number by 2. Okay? I have to repeat this 3 times. When I do this 3 times, so these instructions will be repeated 3 times. Shifting to the left AX1, rotate with carry to the left DX1. Shifting to the left AX1, rotating with carry to the left DX1. These 3 instructions is actually perform step number 3. Okay. Now I have the number of, so actually AX and DX right now after this instruction will carry what? Will carry the number that is called Z. We call it Z. And now this is stored. Z is stored. And Z is basically the multiplication of the value by 8. 53 times multiplied by 8. I want to store it somewhere because I want to subtract it later on. So I will move the value of AX in register BX. And I will move the value of the DX, I will move it into CX. So now this actually completes step number 3. All of those instructions, okay, starting from here till here, is doing the shifting to the right 3 bits and storing Z into backup registers. So I get Z stored. Now Z is stored where? Z is stored in BX CX. Move is just taking copy, correct? Now I finish step number 3. Step number 4 is for continuing this shifting to calculate Y. So I will go, we will continue here with the code. So I will do this shifting again, shifting. Shifting to the left, AX1, rotating with carry to the left, DX1. Okay, shifting to the left, AX1, rotating with carry, DX1. One, two, three, one more time. After performing this, I actually produced what? I get mean, I get the value of Y. If a Y right now is stored where? Y is stored in AX DX. Agree? Makes sense? So I'm finishing step number 4. Now I want to do a double word subtraction. Where is the minion and where is the subtrahend? AX DX carry the minion. CX BX or BX CX carrying the subtrahend. So I want to subtract this from this. So right now I want to perform this step number 4, which is the double word subtraction. This is a kind of a well-known operation. If I have a double word stored in AX dx, and I want to subtract it from a double word stored in bx cx. How can I perform this operation? I have to subtract ax minus bx, and I shouldn't lose the carry because I may get here a borrow from the subtraction. So I have to, the next operation will be subtract with borrow. So I have to sub, the bigger number is ax. This is the minion. يبقى ax bx. This subtraction may end up of a borrow. So the next operation, I have to use SBB, okay, subtract with borrow, which is actually, let's put it a capital letters, okay? So SBB between dx and cx. So those two instructions will actually perform in step number 5, which is a double word subtraction. Subtracting ax from dx, subtract with borrow dx from cx. So right now, my result of subtraction is stored where? It is stored in the destination, ax dx, okay, which is the final answer that I have. This is actually the value of v. We call it v. Okay. If I want to store this in the result is a double word. Okay. So I have actually two registers to be stored, ax with dx. Together they forming a double word number. So I have to put it in the memory in the little Indian order. That means the lower bytes, the lower word will go to the lower bytes, the address, the higher word should go to the higher order bytes. So I have to move, let me just give myself space here for the last step. Move in the memory word ptr at result. I have to move at the word, the first 2 bytes of the memory, I have to move the low order, low means ax. And I have to move in the double word ptr, where should the dx stored? Right after ax. So result plus 2 should take the value of dx. So this actually, those 2 steps is storing the value of the result back of v, stored the memory, which is step number 6. Agree? Makes sense? Any question, any doubts? So this is actually kind of training us how can we design the code for the assembly and then implement it. This is not the only design, or neither only design nor only implement for that code. Okay, there are many ways that you can do the same code. Okay, this is just one example for that. Okay, see you inshallah. We will have a break and we will go to solve the next problem shortly. Thank you.